Okay, so good day, students. Right now, we will be in this graph, and before that, we will be reinforcing some travel graphs which we have previously studied in the last classes. So, as you know, that we have total three travel graphs which you should remember. That is number one. This shows what? Constant speed. What about this graph? This is parallel to x-axis. Remember, the graph parallel to x-axis shows that the object is stationary. Not to forget that we have some different terms as well. For example, constant speed is also known as uniform speed and also as steady speed. So always remember these three terms. And about stationary, at times we write stationary, at times we say that the object is at rest. And about this graph, remember that the distance is coming towards zero, it's coming down. So this shows the return journey. For example, if you started from point A and you went till point B and now you are coming back to your point A, means the starting point, it means you are returning. So for that purpose, you will always draw a line that is approaching x-axis. So these are the three types of travel graphs which we have studied. Now by looking at this example, this is a travel graph. And as you can see that on y-axis we have distance and on x-axis this shows time. By looking at the units, distance over here is in kilometers and time over here is in hours. So if we just look at this whole graph, we can see that this line is basically representing section AB. This is representing section BC. This is C and D, D and E, and E and F. Now, if we, by just looking at these three travel graphs, if we just name what is happening in these lines in this whole journey, so from A to B, this is a constant line. This shows that the distance is increasing and the time is also increasing, but with a similar rate. So remember that constant speed is basically when the distance is increasing with the same rate as time. So we will say that AB is representing constant speed. Remember that the slope of the line also shows the speed. So the slope is basically representing speed. Now I want to give you one more point to remember that if a line is closer to x-axis, it means that the speed is, this is closer to x-axis, coming closer, so speed is less. The speed is slow, but if a line is near to y-axis, means that it is the fastest speed. Plus, you may say that the slope of this line, because you may say that the slope is lower in that area and the slope is at its highest in this part. So you can either talk about the slope or you may use the word steep, slope or steep. These are the terms you can use in your answers to define constant speed with respect to the graph or line. For example, the slope of line A to B is showing the constant speed, or the steepness of the line is showing the speed. Now this coming to the part of section B to C. Remember, this line is parallel to x-axis. Now any line that is parallel to x-axis, like in this graph as well, that line shows that the object is stationary. Means that in this travel graph from 4 hours, because it's starting from 4 and it ends at 6, so the total time taken is 6 minus 4, very simple, 2 hours. So your object was resting for 2 hours. Now from C to D, again, this is slope, this is a line that is a speed. So that again shows a constant speed. But my question is, if you look at line A, B and C, D, which has the greatest slope. If you can also understand the graph, interpret the graph in a manner like this line is showing 4 hours, 2 kilometers in 4 hours, and this line C to D is showing how many kilometers? 2 to 4, 2 kilometers in 1 hour. So even in that respect, you can see that the slope is quite high in C to D. That shows that if you compare AB with CD is more fastest. Now again, DE stationary. The line is parallel to x-axis. And E to F. Now look over here. This is approaching 0 on. So this shows EF is basically the return journey line. But if we talk in terms of speed, so this is a slope. A slope represents what? Constant speed. So this is the whole interpretation of a graph. From A to B, it was constant speed. B to C, your graph was stationary. C to D, constant speed. D to E, your graph shows a stationary object. And E to F, it shows constant speed, but the object is returning over here. Now coming to the point of calculation, because you people are taught how to calculate speed from the graph. So starting the speed calculation for the segment of A to B, if I can just move towards one side and get some space. Let me just erase this. Okay. So for this segment A to B segment, we are calculating speed for A to B. So A to B, what do you need? First, let's discuss the formula of speed. Speed is equals to distance traveled upon time taken. So what you do is, first you look at the distance. Now starting for A, if you look from A to B, this was 4 hours. And if you look at the distance, it's still 2 kilometers. So you covered 2 kilometers in 4 hours. As you can see that the distance is in kilometers and the time is in hours. So you will be getting your answer in kilometer per hour, which would be 2 ones are 2, 2 twos are 4, 1 by 2 kilometer per hour, or you may write 0.5 kilometer per hour. It is that simple. See? Now B to C, it's already clear that the object is stationary, and an stationary object means जब वो चल ही नहीं रहा है तो स्पीड क्या है? 0. Similarly, you know the speed of D to E. It's again 0 because the object is stationary. Now let's quickly calculate the speed of C to D. Now in C to D, we know the formula. We will be using again the same formula. Now see how much distance we have covered. From C to D, C starts at 2 kilometer and D is ending at 4. So from 2 kilometers to 4 kilometers is your segment from C to D. So if you look at the distance traveled, it is 4 kilometers minus 2 kilometers. So that gives you 2 kilometers. And for the time taken, you see that your section C to D starts at 6 and ends at 7. Always drop these dotted lines to get the accurate measurements. 7 minus 6 gives you 1. So you know the distance is 2. Let me just write the formula. The distance traveled is 2 kilometer and the time taken is 1 hour. So your speed is 2 kilometer per hour. So in a similar manner, you will calculate EF, and I hope now you people are clear for the speed calculation. You see that over here, the distance covered is 4 and the time taken is 1 hour. So if I just roughly say distance upon time, so distance is 4 and time taken 1 hour, so your speed is 4 kilometers per hour. See, it was that easy. I hope you have revised